Hi there. Oh, sorry. There we go. That's better. Hi there. We are once again in room 164, our aquaponics lab, and want to tell you about where we're headed next in the course. So, normally at this point in the year, we would actually be in the aquaponics lab on a regular basis, probably 2 or 3 times a week, so that you could actually start running your scientific experiments here in the lab. Now, in this case, I want to go over a few things first as far as some changes that have occurred in the lab that I've noticed as a result of environmental factors beyond our control, namely the weather. It's been cold. It's been a very cold winter. As a result, this kale that normally would be a very deep, deep green, like almost like a dark hunter or forest green, instead it's a very light green, and it's actually wilting at the bottom of the plants now. This is a big change from the last few crops I've had in this plant, um, because environmental factors beyond our control. Okay, it's just that fact. One of those issues is alkalinity, as far as the alkaline nature of the water, which has nothing to do with anything we're doing here. It has to do with something that the city drinking water is dealing with. We're not sure why. Um, that's one of the things that you are all going to find out in this process. Why is the pH what it is? Um, but I'm getting ahead of myself. Okay, so let's take it back to the beginning. Hey, Mr. Headley, why are we here? We just wrapped up Model UN, we just wrapped up DI, and you know what? Kind of wondering what we're going to do next. I am so glad you asked, because we are now going to conduct our own agricultural science experiment growing two kinds of wheat. That's right, wheat. We are going to grow an ancient grain called einkorn, and we're also going to grow a modern grain of wheat, which is simply hard red wheat. And I'll go through those in a little bit. But first, I want to go over how we actually get to that point. Just as a refresher, these are the rafts, these blue styrofoam rafts, and they have holes cut out in them. And in this hole, you will have a bunch of coconut coir, and you're going to have your seeds, and the seeds will germinate, they will grow up, the plant will grow up, and the roots will grow down. And in so doing, we will have a plant that will grow, and it will be phenomenal and wonderful. This right here is kale. That was a spring onion that I simply haven't taken care of. Here we have bell peppers that are growing in various states and sizes. Here are the immature ones. A mature one is back here. I've got a couple around this place, and they're growing decently for the conditions that we're in as well, but not great. So we're going to be looking at all this, but before you actually get into the growing and the fact that they're like, yeah, we do this, you need to have some scientific background on it. And that's the first step. So here we are on the other side of the lab, of the grow beds, and I want to give you a quick reminder of how it is that we actually grow these things. So the grow lights that have just illuminated are a full spectrum light. So this is as close to natural sunlight as you can get inside without actually having a sunroof and natural sunlight hitting things. But it looks really kind of crazy when I'm there and I'm in a white shirt and my bald head goes glowy and I look radioactive. So I'm going to leave it off for right now. But I wanted to show you a few things first before we get into the specifics of what we'll be doing. So first of all, this is one of those bell peppers. I'm not sure how well you can see it. And it is getting very mature given the fact that it is turning red. As opposed to this bell pepper here, which is a very deep green. And again, this is all completely normal. This is going to be very pungent and full of flavor based on what the water is. And it's growing quite well. So each of these flowers will self-pollinate. I tend to help them along a little bit with a small little paintbrush, a very gentle paintbrush, a soft one. And I'll actually, pollinate the plants too, just to make sure that they get pollinated so that we can get fruit. But we're not dealing with peppers so much anymore. I'll do that after we're done with the wheat. Now, wheat is a grass. I'm not sure how many of you remember that or if you've ever thought of it like that. But the different grasses that exist all around the world produce all of our cereal grains. So whether it is sorghum, whether it is millet, whether it is wheat, whether it is oats, whether it is, who knows? I mean, teff, all these different grains that are the seeds of grasses. Some grasses do very well when you cut them and then they keep growing. Obviously, hard red wheat is not one of those because I cut these a while ago, cut them back just so, they'd fallen over because we'd gotten a really bad cold snap and the plants themselves were so wet that they collapsed on each other. So in this case, I cut them. They never really came back at all. So these are just dead. If these were out in the field right now, if it was an open field planted in the dirt, the geese and the ducks would come along and the geese would just munch this all up right away, as would the deer, because there are nutrients in this. It's just not green and growing and like, oh, look, it's fields, nothing like that. On the other hand, this section of wheat here is growing quite well. And it's growing straight and it's green, it's dappled as far as the colors. And this will continue to grow, and you can see the different segmented portions as the shoot grows up, and then it creates a leaf, and then the next shoot grows up within that and creates the next leaf. It's doing quite well, and it's growing straight. It has some support for the wind, because as soon as I turn on these lights again, that is going to power up the fan that we keep going so that we can keep air circulating in here. This is all part of the process here. So what you will be doing remotely, you will be growing wheat, two kinds. In reality, I am going to be planting the wheat. I'm going to be showing you what it's looking like, and we're going to be doing it that way. It's the best we can do right now, and I want to make sure you actually get this experience because this will help you a lot when you get into the actual research mode of what we're doing. So the first thing you're going to need to do is you are going to need to develop a bibliography of white papers. Now, a white paper is a research paper that someone else has done. It's not a really thick doctoral thesis that, I went and defended this thesis and this is what I know. This is what I found out. Not quite like that. What a white paper is it's a less formal, still formal, but it's less formal research. And it's research that can be done usually in a year or less. So with a white paper, you're going to have someone that has done true scientific research that is more of an action-based situation. So we're trying to get information quickly about maybe the growth rates of hard red wheat in an aquaponic deep water raft situation. Oh gosh, we're going to be growing wheat in a deep water raft aquaponic system. Perhaps those are the terms that we should utilize in our search string when we start looking. Because this is a deep water raft aquaponic system. This is hard red wheat. You'll also be growing einkorn wheat, einkorn. And the first thing you are going to need to do is to conduct some background reading, a review of the scientific literature that is available on this subject. So that's where we're headed for the first thing. You're going to, one, you now know what we're going to be doing, where we're going to be. That's the first thing. So you actually know your setting. Two, you know the first thing you're going to need to do is to create a body of literature for you to review. And for that, we're going to get into the specifics in the classroom in just a little bit.